Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, for today's lesson 1.2.1, we are going to revisit what it means for a situation or a relationship to be proportional in nature, which we spent a lot of time in seventh grade talking about this, and we're going to revisit how it looks in a table and in a graph. So just to refresh your memory, proportional relationships are situations where your inputs and your outputs change according to a constant multiplier. Okay, so remember how 0, 0 played an important role with all proportional relationships? And there was that other element with the straight line. Well, the fact that the line was straight on the graph meant that there was a constant growth rate and a constant multiplier in this relationship. So you look at this table, it's like, okay, yeah, I can see that this is proportional, because when I multiply 1 times 3, I get 3. When I multiply 2 times 3, I get 6. When I multiply 3 times 3, I get 9. The fact that we are consistently multiplying every one of those times the number 3, that is your constant multiplier. Okay, so this always shows up in tables. You see the 0, 0, and you see whatever you do to the x variable or x value to get the y value of one of them, you do the same thing for all of them. Okay, and it's just a straight multiplication process. One could say that in this particular situation, that is y is always equal to 3 times x. And that is an equation to model a proportional relationship with a multiplier of 3. Another way to prove, without looking for the constant multiplier, that this particular table includes proportional information is to take any two of those ordered pairs, right? These are XY coordinates, and set them up as equivalent ratios. Remember, when we use proportional reasoning, you would get two fractions that were equal to each other. So is 1 over 3 equivalent to 3 over 9? Or you could flip them and say is 3 over 1 equal to 9 over 3? And they are. And you can test it by looking for a giant 1, right? Multiply this times 3, you get 3. Multiply that times 3, you get 9. So they're equivalent to each other. Or you could do the cross products, and the cross products will always be equal to each other. In a situation like this, 2 over 6 is equivalent to 3 over 9, not because you're multiplying 2 times 3, but in this case, you multiply 2 times 1.5, or 1.5, that would give you 3, and 6 times 1.5 would give you 9. But once again, the cross products are both equal to 18, which proves that everything, all these ordered pairs are proportional in nature. Okay, so we're going to go back and revisit in this lesson what it means to be proportional and just practice with the graphing and all. Okay, so no fancy paragraph at the beginning. We're just going to jump right into it. For problem number 41, we got 3 problems. A involves Parvin. B involves Yasmin's puppy. And C involves Angel. Okay, so your task is to read through each one of these problems, kind of get a sense in your head whether or not you think this is a proportional situation or not, and then create a table of values and plot those points on the graph just to make sure that if it makes a straight line passing through 0, 0, whether or not it's proportional or not. Okay, let's do this one together, and then you can be free to do B and C on your own, and then we'll analyze all 3 of them to see which ones are proportional and which ones are not. Okay, so let's read through the problem. Like the 5D process says, you got to read the problem first and pull out the essential information. Parvin often cleans the dishes for her mother. She cleans 17 plates in 10 minutes. How many plates can she clean in different amounts of time? Okay, so in this one, we're just kind of doing the the hypothetical. What if she spent 15 minutes cleaning dishes? What if she spent 20 minutes cleaning dishes? What if she spent 30 minutes cleaning dishes? How many different plates could she expect to clean in that amount of time? So that's where the table comes into play. So it's like, let's start off with 0. What if she spent no time cleaning any plates at all? Would she get any plates cleaned? And the answer is no, she wouldn't. So there's 0, 0 that comes up whenever you've got a proportional relationship. Okay, so what else do we know? We know this information. We know that 10 minutes was 17 plates. That's what the problem told us. So now let's double the amount of time. If you go 20 minutes, wouldn't you expect twice as many plates, 34 plates? And if you go 30 minutes, you would expect 51 plates, and 40 minutes, you'd expect 68 plates based on these ratios. So does this seem like it's proportional in nature? What do you multiply times 10 to give you 17? I think that's 1.7. You multiply 20 times 1.7 and get 34. Let's check. 20 times 1.7 is 34. Absolutely. So this looks like it's going to be a proportional situation. Now let's look and see what the graph looks like. I'm gonna put the 0, 0 here, and then 10, 17 would be somewhere around here. And 20, 34, what's that, 30, 34 is going to be somewhere around here. That might be a little bit too low. 17, that's, if that's 10 and that's 20, it should be a little bit closer, shouldn't it? So here I'm using my understanding that I know it's supposed to form a straight line, and I identified, ooh, that one looks like it's not really on a straight line with the other one, and I'm pretty sure that's in the right spot, so yeah, that is now in the correct spot. How about 30, 51? That's 50, 51 would be somewhere around here. Does that look like it's on the straight line? Yes, it does. And then 40, 68, 70, 68 is going to be somewhere around here. So for this particular situation, we've got a straight line situation, passes through 0, 0. I think we've got ourselves a proportion there. So go ahead and write that. Okay, now as you do the next two, you might be thinking, how do I decide which goes on the bottom on the x-axis and which goes on the y-axis? Generally, it's safe to say if time is involved, you put the time in the x-axis, okay? In this particular situation, and what we're going to work on more in 8th grade problem solving and graphing, is you're trying to see one thing has an effect on the other. And a lot of times it doesn't make any difference. But in this case, we're trying to look and see how time affects the number of plates that Parvin is able to clean. So we want the time to be in the x-axis, and the number of plates is what you call your dependent variable, which would go in the y-axis. Okay. I don't want you to get confused by that right now. We'll work on that a little bit later. Let's just move to the next problem, and I've decided to put the number of days. Yes, that's the time, goes in the bottom. And for the next problem, the time in years goes on the bottom. Okay, oops, I forgot to label this guy as X. Okay, so go ahead and read through the problem B and C, create a table of values like you see here, go ahead and set up your graph like you see here, and then start filling in, based on what you read here, what you believe are the ordered pairs that would fit into this situation, okay? Now, I do want to stress something. Assuming her growth is constant, that means it changes by the same amount every unit of time. So in this case, she was 14 ounces at birth. That is on day 0, she's 14. So I'll give you that piece right there. Okay? And then 10 days later, it doubled. So it went to 28. From that point on, it's growing by the same amount every single time. So I'll just give you the next one, 20 add 14, right? Because it's 14 each time. That's what we mean by a constant growth rate. Go ahead and pause the video and work on B, and then move to C and read through this and see. I'm not going to give you any hints on this one. You can make corrections if you made a mistake, but I want you to know that you're getting it right without having me sort of nudge you in the right direction, okay? This is somewhat review. This one could be a little bit trickier, but it's okay to make mistakes. We'll fix them. We'll learn from that process, okay? So I'm going to pause the video. You pause the video yourself, and when you've completed B and C, go ahead and unpause, and we'll move forward. All right, let's see how you did. I'm going to move these guys out of the way. So I decided to count by tens here for my number of days. And since we started at 14, that would be, this would be 10, so 14. Oops, stop it, wrong color. There you go. 14 is going to be somewhere around here. So the first thing I notice is 0, 0 is not a part of this process, right? The baby was not born weighing 0 pounds. So that right there is going to tell me it's not proportional. But let's plot the rest of them in. 10 is 28. 20 is 42, 42. And because it did say constant growth rate, I'm expecting a straight line here, right? Every 10 days goes up 14 pounds. 10 days, 14 pounds. 10 days, 14 pounds puts me right around 56, is right there. And 10 days, 40 pounds. So this is an example of a straight line, which is necessary for proportional reasoning, but it didn't start at 0, 0. So it's not considered a proportion. Go ahead and say not proportional. Got it. Okay. Now for the next one. It says, Angel saw an internet pop-up advertisement for investment that doubles your money every year. If Angel invests the $20 her grandmother gave her for her birthday, how much money will she save or have in various years? Okay, so the very first year, she's got $20 to her name, correct? So that would be year one. What is that? 50. So 20 is going to be somewhere. Oh no, year 0. We have not done the 0. So that's going to be somewhere around 25, somewhere around here. Okay. So we know something. It's not 0, 0. So we already know it's not proportional, but I'm not going to write that in yet. It doubles every year. So that means after year 1, it's going to be 40. So year 1, somewhere around here, 40. Year 2, it should be 80, because remember, it's doubling. It's not growing at a constant rate. So it doubled here, now it's doubling there. So 2 brings us to about 80. You notice how that does not look like a straight line? It's because there isn't constant growth. It's what we call exponential growth. Year 3, it's now 160. Year 3, 150, 160 is going to be somewhere around here. And then year 4, it does again, and you've got 320, which brings us to somewhere around here, okay? This is not an example of a proportional relationship because it's neither starting at or passing through 0, 0, nor is it growing at a constant rate. It's growing at an exponential rate. So you get this curve for your graph instead of a straight line. So this is not proportional either, okay? So we've kind of answered this, but it's good to put your thoughts into a complete statement here. It says, which of the relationships in part A through C describe a proportional relationship, okay? And then how do you know that this is a proportional relationship, okay? Looking at the table, looking at the graph, go ahead and write down what we've been talking about. What are the key things that you're looking at to determine whether or not a situation is proportional in nature? Take some time, write a 2 to 3 sentence paragraph, making sure that you cover all of this information here, okay? Pause, take your time, but get this right. This is like a sort of summary the big ideas that we learned in 7th grade, okay? We want to make sure that we've got this under our belt as we move forward because we'll be using proportional reasoning quite a bit still in 8th grade math. And it's really important for you to be able to read through a problem and just determine whether or not it's proportional in nature or not. Okay, so go ahead and write that paragraph, and I will reveal what I have written down. All right. See if what you've got matches what I have. I said, in order to be proportional, there must be a constant rate of growth, which looks like a straight line on a graph, and pass through the origin, which is 0, 0. While both Parvin and Yasmin's situations have constant growth, or a constant growth rate, only Parvin's passes through 0, 0. Therefore, Parvin's situation, that would be part A, is the only one that is proportional. Okay, do you like my handwriting there? Isn't that beautiful? I worked really hard to get it so perfect. All right, now we're going to compare Doug and Johnny with money that they're making mowing lawns. Doug regularly mows his neighbor's lawn. Last month, Doug's neighbor paid him $55 for 6 hours of mowing. Does this sound like it's a proportional situation to you? What's the first thing that pops into your head? If Doug spends no time mowing lawns, will he make any money? No, he wouldn't, right? I mean, how are you going to get paid for mowing lawn if you're not spending any time doing it? Secondly, does it seem logical that he would get paid an hourly rate since he got paid $55 for 6 hours? You wouldn't expect him to make $10 the first hour and then $8 the next and then $13 the next. And then, no, that's not how it works. You get paid at an hourly rate. So that implies a constant growth rate. So that means that yes, Doug is being paid a constant rate, and he doesn't, if he doesn't spend time mowing lawns, he will not make any money. So yes, this is a proportional relationship. So now let's fill in this table. Okay, please copy down this table. Our X would be like our time, although you don't have to graph this, so that doesn't really matter. And the Y would be like our earnings, right? So the amount of money that you earn depends on how many hours Doug is spending mowing lawns. So just to get us started, I believe 0, 0, we've already determined that that applies, correct? And we've got this piece of information. So I'm wondering if I wanted to figure out how much he made per hour, how do you go about doing that? Go ahead and see if you can figure out what his hourly rate is, and then fill this in, and then fill the rest of the table in. Go ahead and pause while you figure that out. And then when you unpause, I'll have figures in here for you to check. All right. Now, one thing to be careful about here is you and I may not have come up with the same number of hours, so your table might look different than mine and may not be wrong. So let's just let's start off by how would we find the unit rate for this situation? Well, the unit rate is what you get when you take your 55 over 6 and say, well, what would that be if it was over 1? And so it turns into, if you remember, a division problem. So if I take 55 divided by 6, what do I get? And you end up getting 9.16 repeated. Okay. Now, I wanted to find that because we are going to be answering questions down here about who gets paid more. And so the unit rate is a great way to test that. So I included the unit rate here in the table. And now if I double the 6, then I'd also have to double the 55. And so that means if he works 12 hours, that would be 110. And if he works, I took another 6 and another 55, 18 hours would be 665. Okay. Now, if I want to check to make sure that's right, let me go back to here. If I take 55 and divide it by 6, right, that's our 9.16 repeated. And now if I take and I multiply 12, or if I take 110 and divide that by 12, I should get the exact same thing, and I do. Same thing with 165 divided by 18. Absolutely. This is an accurate table, and right here is the important part where we've got our unit rate for Doug. Johnny brags that he is getting paid more than Doug to mow lawns. Johnny gets paid according to the graph below. He's getting paid more. All right, so let's take a look at this graph here. In this graph, we see here that, yeah, this is proportional, right? Because if he doesn't work any hours, he doesn't get paid any money. And then it looks like after working 4 hours, he's got $50. And after working 8 hours, he has $100. Go ahead and figure out what is Johnny's unit rate. Okay? And then figure out who gets paid more and go ahead and declare your answer. All right, so here's a little bit more detailed work showing how we figure out the unit rate for Doug. I rounded it up to $9.17. Just because that having repeating decimals doesn't work really well. Now let's check and see if we can do the same kind of work for Johnny. So if Johnny makes, well, I guess we'll just reveal the whole thing here. If Johnny makes $100 in 8 hours, that's equivalent to how much for 1 hour? Well, remember, we do the division. 100 divided by 8 is 12.5. So that means he gets paid $12.50 an hour. So if I were to actually point out that point on here, that's 2 hours, right? So 1 hour would be right there. Does that look like it could be pretty close to, after 1 hour, making $12.50? Looks pretty close to that, right? Somewhere in there, and we'd have to spread out this a little bit more, maybe count by 2s or 4s instead of counting by 10s, and that'd be easier to see that, but that actually does fit in pretty well with our unit right there. So we can declare that Johnny is the winner. He's the one who gets paid more. Okay. Now notice in both situations, you can find the unit rate on the table when your independent variable, your x variable is 1. What is your y variable? That's your unit rate. Here you can see it on the table. When x is equal to 1, what is y equal to? That is your unit rate. And when we're dealing with proportional relationships, many times the unit rate comes into play, and that's an important multiplier for solving problems. Okay, so at what rate do Johnny and Doug each? We already declared that. How do you know? We showed all the work on the previous page. And if it is not already there, how could you show the unit rate in Doug's table and on the graph? We already did that. I highlighted those points for you. So let's just go ahead and move on. All right. Feroza's pet ferret eats so much that Feroza has to buy ferret food in bulk. 5 pounds costs $17.50, and 30 pounds costs $105. So your task is to make a table and a graph, and they say graph, but I always would start with the table first. Have the number of pounds in this case be your x-axis, because the amount of money that you pay depends on how much you buy, how many pounds of ferret food that you buy, okay? So go ahead and set up your table and graph. Go ahead and plug in some numbers, and I'm going to go ahead and give you a bit of a tip there. If you don't buy any pounds of food, you're not going to spend any money, right? So 0 absolutely applies, and we could put that in right here. So go ahead, fill in, choose whatever you want for the numbers of pounds, and figure out the appropriate dollar amounts based on the information that was provided here at the top, right? Let's focus on this. 5 pounds costs $17.50, and 30 pounds costs $105. So make sure the 5 pounds and the 30 pounds show up in your table. Okay, so I'll give you a couple minutes to work on that. Pause and make sure it's nice and neat, and then when you're ready, unpause. All right, let's see what you got here. 5 pounds, that was $17.50, correct? So if I were to double that, that would give me 35. So I'm going to go ahead and plot 10, 35. What are we counting by here? 15s, right? And so that would be 15, 5. And so I need 10 would be 35, would be somewhere around here. And 15 would be 52.50. Maybe I won't do that. Let's do 20 and 70. That's going to be easier to find. 20. And what is that? 30, 60. That's going to be 75. So 70 is going to be somewhere around there. Does that look like a straight line that's showing up? Now you might notice what I've done here. I have not plotted every single one of my points. I plotted the ones that were relatively easy to find. So 30 and 105, if I connect the dots because there's a constant growth rate, that should happen automatically for me, right? Does that look like 30 and 105 here for counting by 15s? Yeah, that's 105 right there. So we've got all of our points. Now I can fit all the other ones in easily because we know those points are going to fall on our line, and I'll be accurate with their placement because the line is already there. So what's the question that they're asking us? Calculate the value of y at point 1y. Okay, so you know what this point is going to be? That's going to be our unit rate. Because we're trying to figure out X is the number of pounds, how much does it cost per pound? And so that unit rate is going to be, that's 2.5, so 1 is going to be somewhere around here, and that's really hard to tell with the graph, isn't it, what that unit rate is. So let's use some proportional reasoning. Go ahead and see if you can take any one of these dollar amounts for the number of pounds and convert it to a unit rate, okay? So we need to figure out how much it costs for 1 pound of ferret food. Go ahead and pause, and when you got your unit rate, unpause and check to see if it's the same as mine, okay? All right, so let's see what we got here. If you just start with the $17.50 for 5 pounds, we're trying to figure out how much that is for 1 pound. So you'll recall, hopefully, that when you find the unit rate, you just do the division, right? $17.50 divided by 5. Some of you may have said, well, why don't you just do 35 divided by 10? And I'm like, yeah, now that I think of it, that's probably a lot easier, isn't it? 35 divided by 10 is 3.5, so that is going to be our unit rate. $3.50 per pound is the unit rate, okay? So I could go ahead and write that here, 3.5, and yeah, okay, there you go. All right, last problem, well, close to the last. Larger bag of ferret food is on sale at Super Pet Mart for $89. Feroza made the following table. Explain to Feroza why the cost of food at Super Pet Mart is not a proportional relationship. So it does have 0, 0, correct? And this is our 5 pounds for $17.50. So what needs to happen here in order for this to be proportional? I'll go ahead and give you the reveal. If you were to use your unit rate, and every time you multiply 350 times this number, you would get that number, then it would be proportional, right? Because you would have your constant multiplier. But 30 times 350 is not 89, so that means that this is not a proportional type of a situation. You do not have a constant multiplier. And if you were to take these 2 points and set them up as a ratio, you would see that the cross products are not equal to each other. So if I took 5 times 89, I would get 445. And if I took 30 times 1750, you get 525. Okay? So if it were proportional, you'd be able to take any of these, write them as ratios, and do cross multiplication and get an equal product. But it doesn't work here, it doesn't work here. If you were to graph it, it would not show a straight line. So those are all reasons where you could explain that it is not a proportional relationship. So go ahead and take some time, write out a brief statement. How do you recognize a proportional relationship in a table? How do you recognize a proportional relationship in a graph? And how can you find the unit rate in a table and in a graph? Go ahead and write a brief statement. Do you see the size of my boxes here? I didn't write a big paragraph here. Just go ahead and write a brief statement to how you recognize, just so you reflect and put down on paper, and this will be a part of your journal as you move forward. You probably won't even have to reflect on it too much because it'll just make sense, okay? So pause it, and then when you're ready, I'm doing the reveal. How do you recognize a proportional relationship in a table? There's always a constant multiplier. How do you recognize the proportional relationship in a graph? Well, there's two things to look for: straight line and the fact that it passes through 0, 0. And then how can you find a unit rate in a table and in a graph? Find the value of y when x is equal to 1. Okay, so let's do our review on proportional relationships. In our next lesson, we're actually going to apply some of this understanding to problem solving. And we're going to review some of the different strategies that we used in 7th grade for finding missing information in a problem that involves proportional reasoning. Okay, so go ahead and move on to your homework. Once again, please copy problems down and show your work. And if they ask you to graph or create a table, please take the time to do it and try and do it neatly. You know, this journal you're allowed to use it when you're taking quizzes and tests, you know, and just make it so it's a good resource for you. So take that extra couple minutes to make sure you're doing things neatly, and you'll be rewarded in the long run. Take care. Bye.
Hey, feeling good.